Dr. Steve Kostell is our speaker today. He's at the University of Vermont, and he has a really, a slightly different background than most people we have on our agronomic seminars, Steve. So I'll let you talk a little bit about your past work. But Steve is a paper maker, and that's how I first met him. And I was so excited about these beautiful papers, which I still have sitting next to me here at my desk, made out of all kinds of crop residues and fibers. And it was probably the most beautiful thing I really ever saw. And it made me really excited to think about the possibilities of making paper in the state of Vermont. And so he's been still plugging away on paper making in Vermont as well as many other things, and obviously has an interest in hemp. And we'll be talking about making paper and some, other fiber uses as well. So, Steve, I'm going to turn it over to you.
Um, I come to this from the perspective of design and really coming out of a craft tradition, particularly looking at hand processes and paper making and really becoming interested in materials and local sourcing materials and starting to explore fiber sheds. And when I came to UVM, I was really excited to learn about Heather's work up at Borderview around industrial hemp. And so I cold called her and ended up meeting her in St. Albans. And I brought my little swatch of handmade papers because it's really like giving someone a box of candy. It's just really nice and tactile and rich natural colors. And paper is one of those materials that's really ubiquitous in our culture and has a really long history. So the other segue into this realm is my interest in systems, and particularly agricultural systems, due to the history of paper making and local sourcing fibers. Sorry, I'm just trying to move. There we go. And so this is a really nice image from a group called Nourish, focusing on a holistic representation of the food system. And I think what's most interesting is the interconnectedness of agricultural's different roles and functions. And to quote Philip Robertson, the concept of multifunctionality recognizes agriculture as a multi-output activity, producing not only products, including food, feed, fibers, agrofuels, medicine, ornamentals, etc., but also human health effects, livelihood, employment opportunities, environmental services, landscape amenities, and sources of cultural heritage. And that's really my entry into collaboration with producers and scientists, and really looking at this systems approach to transition. And so specifically looking at transition design through agricultural systems. And so Terry Irwin, one of the pioneers of the transition design movement at Carnegie Mellon, is quoted as transition design is the process that requires a vision, the integration of knowledge, the need to think and act at different levels of scale, and that is highly contextual through relationships, connections, and place. And that paragraph alone really describes agricultural production in so many ways. The other part of inserting myself into this conversation is really looking at the value chain, and especially in industrial hemp and the developing hemp economy is the missing links within that value chain. And so, we're at the first step of agricultural production, and then we're looking at manufacturing and processing, let alone distributing, marketing, retail, consumption, all of that. And just those first two in the simplified graphic have so many layers of investigation and work to be followed through. So I locate myself more in the manufacturing processing side of things, looking at materials and adopting those materials. So I apologize for the horrible resolution of this graphic. It comes from a congressional research report. I tried to track down the original graphic, which was from, I think, Tunisian hemp producers, and it's no longer available. So, but I guess what I wanted to illustrate with this though is the complexity of the hemp plant and the multiple applications of the hemp plant and the different parts of the hemp plant. And then to contrast that with this graphic from 2015. And this one's much more legible, but it also really serves the purpose of my interest in this conversation, is that as we follow from the top down, we go to the left side and you see the stalks, the herd, and the bast, and then it ends, right? So all of this attention has went to the other part of the plant, the seed and the flowers, and the processes and products around those materials and those outputs. And so there's this huge opportunity that has been around for thousands of years on the other side of this pyramid, around the stalks, the herd, and the bast fiber specifically. So just some really quick background on the plant. Again, I'm not a botanist, I'm not a chemist, so you'll have to forgive me for mispronouncing certain words or not knowing the answers to certain questions that might come up. But looking at the plant from a cross-section view, so this fiber shed graphic is really nice because it's simplified in layman terms, which communicates to me really well. But most important is identifying where the fiber is within the plant and the different types of fiber. And so most of you are probably familiar with the bast fiber and how it easily peels from the herd, especially when it's green. But then that layer in between the secondary bast fiber and where it lies against the herd or the core of the plant, the more woody fiber. And that's an area that produces both fibers, right? And one goes one side and one goes to the other side. And I know I'm oversimplifying this, but essentially these two fiber streams that are really of interest. And even within that, we get into hemicellulose and nanocellulose and cellulose crystals or crystalline cellulose that all have applications. And I'll try to touch on some of that as we move through this. So we know that we can derive bast fiber, herd fiber, and obviously green microfiber, which isn't necessarily high quality fiber, lots of lignin. So we know that fibers are held together. The bast is held to the herd through pectin. There's a lot of non-fibrous material, the lignins, which I believe are primarily different types of sugars and other waxy and, to me, unknown substances, to others probably well known. But we primarily focus on these fiber streams and specifically the bast fiber in the herd. The most common way of approaching the application of fibers as a material is through textiles. And so by starting into processing and starting just by looking at what this process is for isolating these fibers and processing and then even refining. And I think that's a distinction I'd like to kind of draw attention to, is that processing right out of the gate is just separating material streams, where once we start to refine those is where we start to derive a usable product. That's arguable too. I think that you could still use shortly processed or quickly processed material. But looking from the top down, harvesting and retting being a few critical steps. And there's a lot of technology changes around retting, from the traditional field or dew retting or water retting that allows the enzymatic breakdown of the pectins and the lignins, helping to release the fibers and being able to then separate those fibers through crashing and breaking, which we'll look at, and scutching and hackling, and ultimately spinning to threads. And then, oops, sorry about that. And then we can see over to the right, the scutching toe and hackling toe. So yet another fiber source that's not the long bast fiber and it's not the short herd fiber, but it's kind of this middle of the road, and it also has specific market applications. So just to walk through this process, I have this kind of dueling Eastern and Western processing, or European and Asian processing. And the color photographs at the top are from a colleague of mine in South Korea, from a hemp farming village, that the village livelihood is based off of the hemp industry. And they produce hemp for the textile industry specifically. So really high quality hemp. And so in this top photo, you could see where they're stripping the bast fiber off of the herd without decorticating, right? So they're actually steaming it in these huge bundles, tarping and steaming for overnight, approximately 8 hours. But then they go immediately to work and they start to peel off these bast ribbons and trying to keep those ribbons as long as possible. And then to contrast that, we see the handbrake, the first form of decortication, often used with flax and knaf, but also traditionally with hemp. And so after the hemp is dry, we know that the herd is the more woody and more brittle fiber. And so putting it through this break, actually breaking the herd, and then the bast fiber flexes and remains more intact. So the next process would be scutching. And so starting to break the stems off the bast fiber. So there's a machine with a metal roller that's just a gravity weight that's helping to break off those wooden fibers from the bast fiber. And in the above photo, we see again this hand process where you could see a small pile next to the piece of wood and the blade that's being used to pull off the herd that's stuck to the fibers, and that's being put into a separate pile and separated from the really long fibers. This next one, so scutching and hackling, so starting to refine the fibers. The below image, you see they're pulling big handful of fibers through these tall metal spikes. And so essentially throwing it down, pulling it through. And so starting to separate the fibers, the bast fibers from each other along their length. And so the same, starting to remove some of the plant material, some of the lignin that might be dried onto these fibers. Also, in the above photo, you see a very similar process, but done almost strand by strand. And you see this person peeling apart the pieces of bast fiber and then pulling it across this post that's fixed to a base. And it, again, as friction starts to heat and kind of peel off some of that non-fibrous material. So we get to this point of roving. And so roving is stretching the fibers, strengthening those fibers, and essentially creating overlap of these long fibers and starting to create this continuous length of fiber that can be fed in for spinning. And so on the bottom is what you would see named as roving if you were to order this and wanting to spin your own yarns, for instance. Up above the image, they're peeling apart and starting to stretch out the wet fiber. And so in textiles, you'll see a difference between dry and wet spinning, which creates different strength fiber and different tightness in those fibers. And then the last step would be actually spinning, right? And making the threads, yarns or threads. And I don't have a historic picture to put in here, but I really like this image. Just, you know, it's very much the working landscape. And it's kind of this, you know, from a Western point of view, this real romantic notion of what this village does. But as you know, even here in the States, we see a lot of youth leaving rural towns because of what they see as lack of opportunity. And they see these same issues in their villages where the youth go out, receive an education, and then don't necessarily come back to the agrarian lifestyle. So In today's world, so we know that textile industry in the US was really big during the Industrial Revolution. Here in Vermont, we had, well, just down the road in Winooski from me, we had a big textile mill. And the reality of those was as the economy became more global, um, those jobs found their way to more affordable labor sources, right? And so a lot of our textile industry is no longer in the States. There is this company, Belfast Mini Mills out of Canada, and they've actually started to create smaller scale textile equipment. And there's a company out of Minnesota who's actually prototyping their mini mill equipment with hemp bast fibers, specifically looking at batting and felting. So just to go into decortication, sorry, I'm juggling two computers to try to keep my notes in line with my slides. So I got behind a little bit here. So decortication is essentially separating those two fiber streams, right? Taking the plant material, and in most cases, a dry plant, something that's been field retted and is a little bit brittle. And so it's then fed through this handbrake, essentially, which is made up of opposing angled wooden blades. And so it's not to, it's careful not to macerate the bast fiber, but it's certainly trying to break the herd, right? And so there's organizations like FiberShed that have this open source design for small scale operation, individuals who are interested in hand processing. But as we know, hand processing more than a couple dozen plants at a time would become really tedious. As we saw from those early photos of the Korean villagers who were hand processing, it becomes a full-time occupation. And so with the Industrial Revolution, we have 100 person hours equaling 1 machine hour, right? So we see a lot of new designs for decortication equipment starting to come on, mostly focused on flax, but also applying to hemp. And it's interesting, so these images, the one on the left would be a stationary floor mounted decortication machine. The one on the right would be an example of a mobile decortication machine. And so I just mirrored those with contemporary approaches. We see the hemp train industrial system, which we'll talk about a little bit later, a 35,000 square foot facility versus a trailer mounted decorticator, something that can be taken around in the field. And again, something that we'll talk just a bit more. The other interesting thing that's happening now is people are, the maker movement has empowered people, right? And so not only from the scale of like small hand processing, but looking at ways to scale that up. So, you know, these two images of a single operator decorticator, I thought were really interesting parallels. Not only do they both have their arms resting on the machine, but just the reality of, you know, this turn of the century decortication machine that's being hand fed versus this more contemporary machine that has recently come out. So this fellow, I'm trying to see, Kristaps Iglesias, I know I butchered that, but has developed the Herdmaster micro decorticator, which I think is really interesting, and especially thinking about producers who are interested in vertical integration. The ability to manufacture a machine like this and work with a local machinist is very real. So just to kind of walk through the development of some decortication and just to get an idea of kind of how people are going about this. Again, FiberShed working with individuals and creating open source information, making processing available to the individual or pulling together communities, which is then very different than industrial scale, decortication. And you can build these with relatively easily found materials, which is also really interesting. And so, there are plans floating around that can be found. FiberShed does have plans for these brake rollers, essentially. I had to, Heather, I hope you don't mind. Um, this is the
That's funny.
decorticator that is up at Borderview Farm that Heather uses with her team, essentially to do some green decortication, just looking at separating best and herd, and really effective. But again, this is something that was put together by Roger Rainville probably in a weekend, I think. He told me, but I can't remember his exact timeline. And just from parts that he had in his machine shed, electric motor driven, and just I think works really well. Heather, you could probably attest to that, but you seem to get pretty good
Yeah.
results.
Yeah, and he did build it over a weekend.
Good, I'm glad that I was accurate there.
Yeah.
And so it's, the ingenuity that's driven by this, I think, is something that I find really inspiring. And as a designer, seeing people prototyping equipment is really exciting. So looking at some evolution, so we have a handmade decorticator on the left. And you could see that the fibers are fed through perpendicular to the blades of the rollers. We see the bass core decorticator. These images are actually old, that they have the Power Zone stickers on them. And it's now Formation Ag out of Colorado that's producing that, the trailer mounted one. And we could see the trailer mounted one with the baler feeder on it. So a tractor trailer setup. Generator power driven, so diesel generator converting to electricity to run the motors, to turn the rollers. I'm really surprised that I haven't seen a PTO driven decorticator yet. So any of you engineers out there that are inclined, I think there's a real opportunity, especially around field decortication. Looking at the trailer mounted one in the top right corner, and just trying to think about the practicality of following, or even just hand picking up and hand feeding through any large quantity. You could see how quickly it would become a tiresome feat. And then in the bottom right corner, an example, I think that might be Hemp Inc., their facility down in North Carolina. So kind of the big operation that from my perspective, and so I'm going to mention a couple companies, and I'm not endorsing these companies, but I'm really using these as examples of what I see going on in the industry. But Canadian Greenfield seems to really have the most robust and streamlined system that I've seen so far. Everything from bale cutters to fiber separation. This is pre-decortication fiber separation with stone dropouts, for instance, dirt dropouts and all of that, before it goes into the beating and then even, or I should say the decortication and then the refining elements, and to the point where they're able to start pushing fiber streams around, essentially using air and ductwork to move it from stage to stage. 35,000 square foot facility, I think, is their footprint for their largest outfit. They also have these business plans, which again, it's not to really pitch for them as much as to see how they're positioning themselves, but also just kind of questioning how they're looking at these markets. And so you see the bass fiber market where they've identified like concrete fiber, and then other markets, which I would argue that there's some rather large markets that they're clumping into there. And then herd fiber, and looking at cat litter or small dog litter. And 40 million small dog owners in the US, and I've owned large and small dogs, but I don't know that I've ever considered buying litter. So their market analysis is kind of interesting, and I think that there's a lot more opportunity than perhaps what they're looking at. And then we see the green microfiber. part down at the bottom. And again, the more of what we see around the oils and CBD extraction. So let's get into the fiber a little bit. So the hemp hurd or shibs could be used for bedding, can be used for building material, is primarily moved around by the ton. And so these excerpts are from a company, Hempcrete Pro, out of Europe, that sources and sells hemp. And it's really interesting because they do take pre-orders. They only ship within certain ranges for certain products. But what they have done is they've started to standardize the units in which they ship, what minimum purchases are, what type of availability there is, and they also note where it's shipping from. And I think that that's also kind of critical. I know when I'm sourcing dry lap for paper making, dry lap hemp, I'm acquiring it here in the US, but it's coming from Spain, right? So where is it coming from prior to being pulped down to that lap sheet? And so that's part of my interest too, is trying to sleuth some of that trail of where these materials are being sourced. Oops. So this is another company out of Colorado, and I'll talk about them a bit later, but Pure Hemp Technologies. And you could see their pricing structure around hurd. And they've also started to break it down into different size hurd. And so when we look at the hemp train unit, it has different shaker tables that are able to start to parse these different hurd streams, which is really interesting because they all have different application potentials. So another way to talk about hurd specifically is the bulk density of the hemp. And there are actually standards that have been developed specifically for the biofuel industry, I believe. But thinking about, what are these uses going to be? What type of markets are they going to fill? And thinking about fiberboard, different size hurd could produce different size boards. And we'll see some examples of that later as well. So Canna Grove, one of these companies who's sourcing and producing materials, you can see they've got different specs on these 3 different boards for thicknesses. They also have different flex or durometer strength to them. They're producing hemp wool. They're selling hemp hurds. They're selling binder material, essentially lime. They're selling their Hempcrete kits, and they're also pushing sample of their hemp boards to try to get it out into people's hands. Their method of Hempcrete, I think, is really interesting, and a lot of you have probably seen it. And I didn't include any photos just because, again, it's really a laborious process of hand tamping. So first mixing the lime binder with the hemp hurds, and then hand tamping it between forms to construct the walls. And I really think that there's a better solution to that, which we'll get to. And then just an example of some different types of composite boards, and really looking at the density of the boards, the fineness of the material that's in these boards. And I'm always a sucker for material glamour shots, so I had to include some of those. And then we have the hemp bast fiber, which seems to be the other source. And most people attribute hemp bast going into the textile industry. And so again, this is from that supplier in Europe, and looking at how they're supplying it in these tall bales. It's not a combed hemp fiber, so this is just freshly decorticated. It still has chunks of hurd stuck to it. It's not separated, lots of lignin. And then ships from Poland, which I also think is interesting. So these different countries sourcing different materials. And so, I think the most obvious, lowest refining use of bast fiber is really looking at non-woven hemp. And I had mentioned that company earlier out of Minnesota. Who is it? It's Egg Processing Solutions, and they're teamed with another company called Forsberg Incorporated. And they have in-house decortication and separation. Um, and then they're the ones that are using the milling equipment to do the batting, and primarily looking at agri-textiles, ground cover erosion control textiles, weed suppression type of textiles. But then there's the whole building industry looking at acoustic insulation, temperature or housing insulation, sound insulation. So I think a lot of opportunities to be explored with the non-woven. So the next extension of the Hempcrete is really looking at the brick form, and there's a lot of different makers or producers of Hempcrete based bricks. This one I think is particularly interesting because it's incorporating clay, and I'm really interested in this personally. But I really like the fact that they have these 3 different module style bricks that they're working with, which allows more flexibility with the build. So 3D printing. 3D printing in Hempcrete, I think, is a huge opportunity, and there's a couple companies that are doing that now. There's a company based out of Australia. Trying to find their name in my notes here. And then a couple of companies, there's one in Italy that's also working with this. I'm almost there. So Icon is the company that's creating these large scale size 3D printers. And so the image on the right actually is a job site in Austin, Texas, where they're 3D printing a series of homes. There's a really interesting community-based story behind that. This company has also developed temp panels to be used in residential and commercial building projects. And they can be manufactured directly through the 3D printer, so essentially print on demand. The other company is the SQ4D. And so this is the company that I think is kind of the most futuristic. So they're Australian-based biotech company. Is it Morocco, I think is the name. And they've got, they're actually 3D printing hemp homes. And we could see the 3D printed home, that's the SQ4D, the largest 3D printed home, not using Hempcrete, but I think, again, this great opportunity considering the insulative properties, the fire retardant properties of Hempcrete. I think it's a natural, and especially looking at 3D printing technologies and the scale at which we're able to start doing that. Other low-hanging fruit, I think, is really looking at biomass pellets and briquettes, and especially thinking from a Vermont perspective. And if I'm a producer thinking about easy ways to start to thinking about vertical integration for value added. Specifically looking at whole hemp conversion. And if you're a CBD grower, we know that CBD doesn't necessarily yield the best bast and hurd fibers. But this is certainly a viable option, I think, looking at biomass energy applications, providing heat, electricity, fuel, the direct combustion of hemp biomass used to generate heat in conventional wood stoves. So produced as pellets or briquettes, and then depending on the specific equipment, they can have hollow cores and can also be carbonized into briquettes and or biochar. So the other interesting fact about the hemp pellets is they have a really low ash content. I think it's right around 2%, which competes really well with wood. It can vary as any material, and I think that that's one of the things that looking at the different cultivars that are being grown and starting to identify what those characteristics are from cultivar to cultivar. We know that different strains grow different ratios of hurd to bast fiber, have different amounts of lignin in their materials, but they'll also have other differences as they become used and included into different applications. So this is a biochar facility that converts coal briquettes. And I'm just always, again, interested in these kind of industrial shots, but more so just looking at the scalability. And so using, these furnaces versus using charcoal kilns through crushing, drying, briquetting, charring, and carbonizing, and then ultimately distributing or using. So ultimately, it comes down to fibers. And I'm going to transition here a little bit and talk specifically about the hemp fibers and what makes them so interesting. So this SEM stereoelectron microscopy image, stereoelectric microscograph, micrograph, looks at hemp, canaf, cotton, and polyester. So from the top to the bottom, left to right. And we could see the hemp and canaf have a lot of similarities in their structure, in their interlacing. When we go to cotton, it's a much bigger fiber, much more airy fiber, and then obviously polyester being a synthetic, much more uniform. And the other interesting thing is just thinking about the scale. 1 inch holds over 25,000 micrometers or micron. And so we're really talking about this real tiny scale when we start talking about fibers. So ultimately, we're interested in cellulose, right? Bast fiber, hurd fiber, it's all cellulose. It's different lengths of cellulose structure, but ultimately it comes down to the cellulose fiber that we're interested in, and it's the way that those fibers interact that gives them their structural integrity. So as a paper maker, this is where I became most interested in plant material and specifically hemp, is due to the amount of cellulose. And so we know that the hemp plant is about 70% fiber. And from that, we have, the hurd and the bast being about 13% of that fiber source. So thinking about the volume of these different fiber streams and what they can be used for. And then again, ultimately coming back to this idea that we're working at this level of cellulose and using or incorporating it into these different products. So this is an image of cellulose that's been beaten in the paper making process. And we can see all these little fibrils sticking off of it. And so what happens is we score these cellulosic fibers, we're starting to create more surface area and more bonding sites. And that's what gives these materials their structural integrity. As far back as 1916, you could see the USDA was doing research on hemp hurds as a paper making material. And so looking at the paper making process, which I think is obviously my gateway into this, the beating process is often a synonym for refining the fibers. And it works by passing the fiber in a slurry of water between the rotor and the stator, essentially metal teeth that are coming together. So much like the decortication process where we're running it through these metal rollers to break the hurd, now we're putting it through a finer set of metal rollers that are mechanically macerating those fibers. And so a couple things, it's chopping those fibers, shortening the cellulose, but it's also fibrillating those fibers, right? Creating all those kind of offshoot fibers. And at the same time, it's hydrating these fibers. It's encouraging it to take on water, which then becomes a really important part of the paper making process. So this idea of fibrillation, putting it through the beater, macerating the fibers, breaking down the cell wall, um, delaminating those cell walls, and then exposing those microfibrils, and then introducing that water to the cellulose, becoming that real critical component. So then once the pulp slurry is created, it then goes through a process of sheet forming, wet sheet forming, just allowing a real uniform alignment of those fibers, and then a drying process. And it's through that drying process that we get hydrogen bonding, which then allows that cellulose to rebind with one another in a new way. Really interesting things happening though with retting and with pulping. So this Pure Hemp technology company out of Colorado has developed this process called continuous countercurrent reactor, where you're feeding in feedstock and you're pushing against it with a liquid reagent, a heated liquid reagent that's actually macerating these fibers and producing pulp, and at the same time producing this liquid extract, or liquor as it's referred to, that's full of lignins. Any non-fibrous material is essentially coming out of that end, and that liquor extract can actually be used then to start to isolate polymers. So interestingly, this company has been working with International Paper and developing a hybrid line of paper just across the lake from us, and in their Mohawk specialty paper line, and they're incorporating up to 30% hemp fiber and then other recycled, mostly cotton fibers, to produce these papers. And so we see, a roll of paper that comes off of the web production. We see cut sheets of paper to the right of that at the top. At the bottom left, we have the dry lap pulp as they would receive it from their supplier. And then on the right is just like a bunch of overrun paper that's probably going to be discarded or actually recycled into their process. So Hydrogen Link is another company that's really interesting, and they're using a kind of a similar process, using a reagent to ret these fibers as well as to cottonize these fibers. And that's, I think, one of the things that we see post decortication, as we start to get out of processing and into refining, is really how these fibers can start to be used and take the place of like cotton fibers, for instance. And so cottonizing hemp is this whole new area that's really taken off, but primarily, looking at removing, again, the lignins, the gums, and even the hemicellulose, and trying to just get those long cellulose fibers. So another image showing they're referred to as technical fibers, essentially, but showing the Bass ribbon to the left and then their process. And again, they're not really sharing their reagents. We know that there's sodium hydroxide that's being used, hydrogen peroxide that's being used, but they're not really sharing the percentage. All of that's being trademarked and licensed. And then I've even seen some of these companies opening opportunities for partnerships, business partnerships. So some other images. Steam explosion is another way of retting and breaking down the cellulosic fiber. And so in steam explosion, again, they're using a reagent. They're heating it and putting it under extreme pressure and then rapid decompression, and using that as a way to break apart these fibers. So again, being able to take a green product and completely mitigate the retting into a lab and isolating the cellulose, also isolating hemicellulose and nanocellulose. So we see it already showing up in products, right? Cottonized hemp. Levi's did a really big campaign not too long ago. And then the last process that I'm going to talk about is the ultrasonic fiber processing, which is still pretty new. Really looking at, I guess, yeah, just ultrasonic processing. So the reduction of lignin content, micro and nanofibrillated fibers. So being able to isolate those fibers, but then also being able to supply a clean, long bast fiber. These are particularly suitable for polymetric resins, thermoplastics, thermoset composites, and then also a valuable source of cellulose nanocrystals being extracted through this process. And so these aren't as explicit in seeing what's happening, but being treated again with the reagent and then being put under the ultrasonic process to then break apart those bast fibers and herd fibers. So looking at enzymatic hydrolysis, which is also a part of this, and again, this science is getting beyond me, but also just really fascinating in the way that we can look at fermentation. And I was talking with Heather before this talk about just looking at some simple fermentation essays around breaking down the bast fiber from the herd, but doing it at the laboratory scale here, it's really interesting to see how they're able to start to identify specific pathways for very specific byproducts that come out of this. And so again, this idea of thinking from a systems perspective of a biodigester on a farm that's able to convert energy is able to output pulp or other fibers that can be rolled into pelletizing or other needs, I suppose, or a potential off the farm value added. And so some applications of these processes, PLA, 3D printing filaments, and looking at how those filaments can start to be adopted. And most of these PLAs are only 25% hemp. Kinesis is up to a 30% hemp, and then they're using other plant-based polymers. You can see the pellets in the glass dishes that are then fed in for different types of thermal forming processes. Really neat designs. I don't know that they've really been tested for their integrity, especially thinking about carbonated and or reactive types of products that could be put in them, let alone heat. And then someone had asked about hemp hurd being used as a graphene replacement. And it's interesting, so in trying to find some information around this, most of the information was pointing towards the use of bast fiber, but really looking at, again, the nanocellulose, which can be extracted from either, but then essentially using a composite made up of layers of lignin, hemicellulose, and crystalline cellulose to create essentially a carbon nanosheet that can be used to start to build superconductors. So the process of utilizing hemp fiber through hydrothermal synthesis, which hemp fiber is cooked and dissolved, all the lignin and hemicellulose substances, leaving carbon nanosheets behind, and they refer to it as a pseudographene. So there is one person that's doing, David Mitlin up in Canada, talks about supercapacitors considerably in his research specifically, and the ability to start to create this at scale. But right now, it seems like all of this research is really limited to laboratory scale, right? It hasn't been able to scale up to application, but it does seem like it holds a lot of promise. And so these images are looking at nanofiber that's been processed through the ultrasonification process. And so this, I believe, is what you wouldn't be able to see that would be then used to create these graphene-like superconductor sheets. But the ultrasonic process, breaking those fibers up even more, and then being left in with those lignins. So a list of different URLs at the end of the presentation here that just look at the different companies that I kind of pointed out, and I'd be happy to take any questions.
Okay, so amazing. Do you see the ultrasonic process being used to eventually replace plastic products?
I'd love it. Sure. Yeah, I think that we all know the reality of the amount of investment in plastics, and it's a long game. And that's the interesting thing about transition design, is that it's not about quick fixes. It's about really establishing, visioning these futures, and then establishing benchmarks of achievement towards those futures. Yeah, I think that there's a real possibility that we could use all plant-based material, but I was speaking with a new collaborator over in our engineering department, and she was talking about the difference between petroleum-based plastics and plant-based plastics, and that heat is a huge factor, and that you can heat up petroleum-based and reform, but when you heat up the plant-based plastics, you're cooking those fibers, right? And you're altering their characteristics. So, I think that it's going to be interesting to see the evolution of the adoption of plant-based plastics, but absolutely, I think it's a reality.
That's really great. Do you know much, Steve, about the relative insulation capacity of hemp compared to fiberglass or any
So,
other insulation type
no,
thingy
I'm not
products?
sure about like specific standards and ratings, and I do know that it has a lot to do with the fiber density, um, and then ultimately the thickness of those materials. And so that's where processing, especially in bast fiber, in breaking apart those fibers, can make a difference. So thinking about really crude type of fiber mats, where it very much has the characteristics of the plant in the product, versus material that's been processed much more, so it's a much finer fiber, is going to have much higher insulative properties. But yeah, I couldn't speak to specifics.
Great. Let's see here. Can the fibers be used like sandbags?
So like bags full of herd fiber, or as bags to hold sand?
Ooh,
Both. Um,
there you go.
so, I think that from an absorbent perspective, thinking more about like the oil spill absorbent dams, they're lightweight, but they're really absorbent. And the weight comes from absorbing that material. So the more the hemp dries, the lighter it gets. So it wouldn't necessarily have the weight of a sandbag. And I think that, a sandbag comes from the density of all of that material piling up and holding back water, where a herd specifically would be absorbing the water. So working kind of differently in that regard. From a textile perspective, I've seen very rough and loose woven textiles to very fine textiles through hemp. So again, just depending on that refining of those materials would determine those characteristics and the tightness of that weave.
Right. So we have a couple more questions and we are at time, so we'll wrap up with these two. Um, is there a conversion like you can make 3 pairs of jeans from an acre of hemp? Or something like that?
I think that Heather's trying to answer that through her research and looking at what fiber yields are, right? And I think that
Mhm.
that's the big unknown is these different cultivars grow different thicknesses, different heights, grow at different densities. And a lot of that information is going to be, um, I think, based off of those specific growing conditions that are going to inform what that yield would be.
Yeah, and it definitely seems to differ year to year. And yeah, and the things that Steve is evaluating with our fiber is really different than what we're looking at. So working with him has been great to give us a very different perspective. So there's a lot more to learn there for sure. Is hemp paper suitable for printing and office use? And if so, is it available on the market?
So absolutely. Again, through the paper making process, you can control those characteristics of how fine those fibers get. Um, it's a relatively costly fiber right now. Um, and something like wood pulp is really cheap. Recycled paper is really cheap, but there's also structural integrity that changes. So using something like hemp fiber, it's going to be really strong, um, thinner sheets, where when you're using recycled material or wood-based fiber, it's much shorter cellulose chain, so much shorter fibers, much weaker paper. Um, and I have seen some, well, like the Mohawk paper, for instance, that's absolutely commercial printing paper, commercial packaging paper. I've also seen hemp craft paper. So craft paper is the brownish gray paper that we make cardboard with. And looking at different grades of that for the outer sheet versus the corrugated sheet that's in the sandwiched in between. But definitely all printable. From an office paper perspective, I'd love to see it. I know that there's a company out of Canada that's um, really big on wheat straw and has been moving into hemp, and they do make a office grade paper. So I would anticipate it.
Hmm, great. Well, everyone, oh, wait. Look up Tiny E paper, new startup in the USA.
Tiny E?
Tiny, capital E, and then paper.
Mm-hmm.
Thanks, Willie.
Yeah, I like
And
that tip.
yeah, well, thanks, thanks, Steve. This has been great and very informative and exciting to see the opportunities and see things are, we're making progress. You mentioned that mill in, is it in Canada? The making the small scale fiber equipment. I can't remember the name of
Yes,
it. Yeah,
Belfast.
Belfast. There we go. It's really interesting. We've been working with them with the milkweed project that we have, and they have made some material out of milkweed for us, and they are really innovative and a process that other people couldn't really do. They just like did it for us, and so it's really exciting to have them there and available. I'll also mention that the folks in Minnesota that you speak of, I think they're speaking at our hemp conference. Is it the
Oh,
same
awesome.
group? So they're working on farm diversification and lots of other projects, but they are working on small scale hemp fiber processing. So they'll be at the conference, UVM conference, talking about their work. So exciting. All right. Well, you're off the hook now. Thank you. We really appreciate it. And I love this presentation. Thank you very much. So
It's
there you
always
go.
fun to put something like this together because I learned something new.
Yeah,
So.
good. All right. Well, thanks, Steve, and we'll see you soon. And